Oh, hi, sir.
How are you doing?
I'm good. How are you?
Good. So we also have Najib from Germany. So I'd like you to
Hi.
introduce yourself, right? So Amy, introduce
Okay.
yourself, and then Najib, you can introduce.
Okay.
Hi. So I'm Amy Alexander, year 12 student based in the UK. This whole concept of calculus is like quite new to me, so it'd be really good to get a good understanding. So that's why I'm on this session.
My name is Najib. I'm from Germany, and I have also a lot of problems in mathematics. I'm studying engineering, and I hope also that I will succeed in mathematics with Mr. Anil.
Welcome, both of you. I've made an attempt to make you both understand a part of calculus. And now for me, the challenge is that you are like two extremes of my student group, since Amy is being introduced to the subject, whereas Najib knows quite a bit about it. And he is in the university. You have yet to go to the university, right? So in my videos, I'll kind of take a very basic approach so that Amy, you will be able to understand. And likewise, any student who is like year 11 or year 12 could easily understand the videos and join our passion of learning. So did you watch the video which I post, both of you?
Yes.
Yeah.
Okay, that's great. So we'll basically discuss that part of video. It becomes easier if we know what we are discussing, right? Especially on Zoom like this. Now, was there anything which was difficult for you? Nazib, did you find anything which was confusing or not very clear?
No, I think everything was clear.
Okay.
It's not.
How about you, Amy?
I think the only thing was, with the table, it was a question where it was like x squared, and then it was like x squared minus 1 over x minus 1.
I see.
So is that like the formula where you get minus 1 from the like y2 minus y1 over, is that like a rule?
Yeah, that was actually, yes. So that table had actually 3 columns. In the first column, we had the x values. Those x values were approaching a value 1. And for each x value, we calculated x squared. So that was the second column. So if you see the function, which is y equals to x squared, in that case, x squared is the y value, correct? For every x value. Now, if you want to find the slope of a line, which we are saying secant line, since this line is going through 2 distinct points that they are far apart. So we have taken one point on the curve, y equals to x squared at 1, 1, and the other point is at 2, and 2 squared is 4. So right. From there. The slope of the secant line will be y2 minus y1 divided by x2 minus x1, right?
Yeah.
So the formula is written right on the top. Y2 happens to be x squared, right?
Oh, so you just
y1, y1 happens to be 1, correct?
Okay.
And that is how you get this particular formula. And then you substitute those values and calculate the result. I will just, I think I can take out this page and share with you what we are talking about so that is clear to all. So I think we are talking about this particular table, and right there, when you see this x squared minus 1 divided by x minus 1, correct? You're referring to the same page? Perfect.
Yeah.
So that is on the left side of this. This is actually a very important concept to begin with, and that's a real starting point. So we have taken the curve y equals to x squared, and I've taken a point P here, which is at 1, 1, only for easy calculations, right? You could take any point for that matter. And then we have considered the second point Q, which is at 2, 4. So here is the table in which we have x squared, and m equals to x squared minus 1 divided by x minus 1. So you'll notice that we started with the x value of 2 and gradually decreased it to 1.5, 1.2, 1.1, 1.01, 1.001, and even 1.0001. That is extremely close to 1, correct?
Mm-hmm.
Now, as you approach extremely close to 1, that is the Q point is being moving left and coming closer and closer to P, the slope of the secant line becomes very, very close to the slope of the tangent line. They kind of overlap. So at this stage, we say, well, the secant approaches tangent, and that is how we define tangent in calculus or otherwise. So as you see here, tangent is actually the slope of the secant line when the secant line approaches the tangent line. Does it make sense to you? From the calculations also, which is the third column for you, m equals to x squared minus 1 divided by x minus 1, we see that initially the slope was 3. Now it becomes 2.5, 2.2, 2.1, 2.01, 2.001, and then 2.0001. So all these calculations show us very clearly that the slope is approaching to 2, and therefore we will say that the slope of the tangent at 1, 1 on the parabola y equals to x squared is 2. Does it make sense to you now?
Yeah.
Now, when we go deeper into calculus, then there will be few problems where we will see work out the percentage error in the calculation, right? So let us say we stop at this point and we say the slope is 2.0001 and actually it is 2. Then later on, you might be required to find percentage error, which is 2.0001 minus 2 divided by 100, divided by the initial value. Is it okay? So those are the kind of problems which will be very difficult questions at a later stage. But based on this. Now, the interesting part which I want to point out with this particular observation is that we did all this calculation to get to the result. And the result is that the slope of tangent line at point P, which is 1, 1, is 2.0001. Now, what we did was we generalized the point. We say, well, let's take this next look, right? We are still considering the point P at 1, 1, right? But we take a point Q, which is h distance away. In many books, we write delta x. Delta means small value, correct? So I'm not starting at 2, 2, 4. I'm starting at a point which is very close already, but I'm saying that the distance is not x, but x plus h, or in some books, as in your book, x plus delta x, where delta x or h is a very small number. In this case, most of the time, we'll take h as 0.0001 as written on this page, correct? Now, on this function, we have a point 1, 1, which is p. The other point, which is q, the x value is 1 plus h. So what is going to be the y value, Amy? Function is y equals to x squared. The x value is 1 plus h. So what is going to be the y value?
1 plus h squared.
Perfect. So that is what it is. And therefore, we have the point Q where the x value is 1 plus h and the y value is 1 plus h squared. So that is like y2 for you. We can now find the slope y2 minus y1 divided by x2 minus x1. x1, y1 is 1, 1, right? y2, y1 is 1 plus h and 1 plus h whole square. So applying that formula, we get 1 plus h whole square minus 1 divided by 1 plus h minus 1, expanding the binomial to the power of 2 and then simplifying and then cancelling the h as shown here, we get the slope as 2 plus h. Perfect. Now notice, if I substitute h equals to 0.0001, I get the slope as 2.0001. Do you see that? Without any calculation. So accurate. Perfect. Does it make sense?
Right. Yeah, makes sense.
That's the beauty. Now this particular approach we can apply to any function. We just chose y equals to x squared for simplicity. It could be anything. It could be sinusoidal function, it could be exponential function, it could be logarithmic function, it could be combination of all these functions. But the concept remains same. Perfect. Now, the important thing here is, since you see that this can help you find tangent at a point on any curve, is half of the calculus, right? As we introduced earlier, calculus is divided into two parts. One part says to find the tangent at a particular point on the curve, and the second part is to find the area under the curve, or even combination of curves, right? So that is the integration part. So in our part one of calculus, where we will be discussing derivatives, in that this becomes a critical part to understand. And so we give it a name. The name to this is derivatives. So this definition that the slope of the secant line approaches the slope of the tangent line when the point H is very, very small. That is the limit of this point, let's say P to Q, distance between P to Q, that limit approaches 0. When that is true, we actually get the derivative of the function, and the derivative directly gives you tangent at any particular point. Does make sense to you?
Okay.
Now,
Yeah.
this is a kind of tedious process. We will actually stick on with this process and work out many functions so that we get an idea of how to work with this kind of an equation. This equation is also called difference quotient equation. So you can make a note of this. It is called difference quotient equation, which we can write as something like this, as shown here in the next slide. So in the next slide, what we are trying to show is it could be any curve and any point. And as shown here, we have a very typical curve here with a tangent at P. And to find the slope of this tangent, what we need to do is to figure out a point Q, which is A plus H. The value of the function will be FA plus H. Slope will be Y2 minus Y1 over X2 minus X1, which you can now find F of A plus H minus F of A over A plus H minus A, and denominator will be H. You can substitute a value of H as 0.0001 and get a number, and that number will be the slope of the tangent at that particular point on that curve. Does make sense to you? This is called the difference quotient formula, which is highlighted for you just at the end, and it works. So when we say m equals to f of a plus h minus f of a over h, a is that value of x equals to a. Do you get the idea? Correct? So that is the introduction to limits and also to derivatives. So in our next lecture, actually, we will focus more on application of this difference quotient formula with different kind of functions so that we become conversant with how to use this formula. Perfect. And solve many different kind of questions. I have a question set for you. So I'll post you a set of questions to work on, and also a set of 10 questions for which I have a solution video also. So I'd like you to go through that video, pause, answer the questions, and then look into the solutions to master what we have learned so far. Perfect. But I think what you need to do at home also is do at least 20 questions on any topic we do, because practice will make you understand all these concepts. They may look very simple, but they are not that straightforward. So you need huge amount of practice. So solve all the questions which are there in your book, and I'll give you some additional questions which will be from previous test papers, and surely they will help you to perform much, much better in your own test or exam. Perfect? Right? Does that make sense?
Yeah.
Okay, so any questions at me now?
No. All makes sense.
Makes sense? Yeah. Najib.
For example, if fx is equal to 5x.
X to the power of 5.
Yeah.
Okay. Then, see, that's a very good question, Najib. If instead of x squared, we could have x cubed, we could have x to the power of 4, we could have x to the power of 5. And now the problem is, how do I do a plus h to the power of 5? You use Pascal's triangle. So in Pascal's triangle, you could expand, and the coefficients you can pick from the Pascal's triangle. So that is one part which we can look into. So did you apply Pascal's triangle sometime? X to the power of 5?
I use the simple formula, you know, a squared plus 2ab squared plus
so I
b
think
squared.
yes. So I'll share with you some videos on how to use a Pascal's formula, Pascal's triangle actually, to get the formula for binomial powers, correct? So any binomial power we could do. The other formula which is also very common is using combinations. So we'll not get to combinations, it becomes slightly more complicated, but we'll restrict ourselves to binomial expansion using Pascal's triangle. At the end of this particular session, I'll actually post some videos for you to go through, and we'll have an example x to the power x plus x to the power of 5 and working with that. Right? So Amy, do you see the importance of Pascal's triangle here?
Yeah.
So that a plus h, right? If the function is x to the power of 5, then that becomes a plus h to the power of 5. So you know first place how to expand it, correct?
Yeah.
Not too much, right? So you should know that, and then you can do it. So that is where the Pascal's triangle come in, and that's a very, very important thing to work with. Now here, I had taken an example, which is also a very good example. So this example is, consider the function f of x equals to x cubed plus 1. So that is the function we have taken. So now we move from x squared to x cubed, increase the degree by 1. And most of the students know what is a plus b whole cube, right? A cube plus 3a square b plus 3ab square plus b cube. So that is the expansion for a plus b whole cube, right? So if you do the Pascal's triangle, you will also get the coefficient as 1, 3, 3, 1. And these 1, 3, 3, 1 are actually the coefficients for this particular expansion. Perfect. Now the question here is, find slope of tangent on the curve f of x at x equals to a. So we have not given you the value, we just given you a general point a, correct? The second part is, at point q on the function f of x, slope of the tangent is 12. Find the coordinates of q. So we have flipped the question. We are not saying that the value of x is 2, find the slope. We are saying that the slope is 12, find x, right? So that particular equation, difference quotient, could be used the other way also, right? So basically, you have everything which is known. One thing is unknown that could be found. And part 3 is find equation of normal at q. So we are not asking you for equation of tangent, we are asking you equation for normal. As you know, tangent and normal will be perpendicular, and the slope of the normal will be negative reciprocal, right? So to find, with the help of difference quotient, slope at a particular point, let us say we are considering this point, in that case, normal will be negative reciprocal. So you can go through, change the slope to negative reciprocal to get the slope of the normal, use the point and get the equation of the normal, correct? Perfect. So that is how it could be done, right? So that's what I was trying to say. Now here are some questions which I just now typed in for you. So these are 4 questions which I think are very interesting. The very first question is, given e equals to limit x equals to 0 for 1 plus x to the power of 1 over x. Now that is the definition of e also. So number e is so important. You've done in exponential functions, logarithmic functions, correct? You know it's a rational number, perfect. And that's the formula for it. It is 1 plus x to the power of 1 over x where limit x approaches 0, right? Sometimes we do flip x as 1 over x, right? So we just change it and we say limit x approaches infinity for 1 plus 1 over x to the power of x. So we kind of flip it sometimes, ask the same question.
Oh.
You can exactly find the value of e using that table which you were talking about. So keep on writing the values of x which are very close to 0, right? So you could begin with 1, take a value like 0.1, right? 0.01, 0.001, 0.0001. So when you do that 0.001, that is 4 decimal places, you will actually get a correct answer to 4 decimal places, right? So that's how you're going to answer the very first question. Question number 2. At point P on the parabola, y equals to 3x squared plus x, the gradient is 13. So in UK, you use the word gradient more than slope. Slope and gradient are one and the same things. So we are given that the gradient is 13. Now the question is, find the coordinates of point P, the point at which the gradient is 13, right? So you have to do the reverse calculation. And part is, find equation of tangent line at this point, right? So that's very clear. Once you know the gradient, the point, you know the equation tangent line. Question number 3 is, the point A lies on the curve f of x equals to x cubed. At point A, the curve has gradient of g. Perfect. Now, here is another question. When we are talking about the gradient, is it a value or it is a function? So when I say f of x is x squared, the gradient is, let us say, 2x. 2x is a function. Do you understand? So in calculus, when we are finding a gradient, we are actually not getting a number. We are actually getting a function. So we could graph that function also. So for a parabola, the slope, or I should not say the slope, so I should say the derivative of the function will be a straight line, 1 degree lower. That is what we are going to observe in our next lecture. So whenever you're looking at the gradient of a function or a derivative of a function, it is a function itself. It is not a point, correct? That is very important to appreciate as we move along. So question number 3 says, the point A lies on the curve f of x equals to x cubed. At point A, the curve has gradient of g. That means g is a function, okay? I could have written g of x. Write an expression for g. So the other side, g of x equals to what? That expression. Show that the gradient g is limit h approaches 0 for h squared minus 3h plus 27 at x equals to minus 3. So in your question, when you substitute the value x equals to minus 3, you will get that expression. It's kind of a check for you also that you derived at the correct result. And the last part, C, is find equation of the normal at A. Perfect. Question number 4 here is, the line L is tangent to the curve y equals to 3x squared plus 1. L cuts y-axis at 0 minus 11. Find the equation L. So that's another very brilliant question. I would like you to actually take a snapshot of this, or copy this, and actually do these questions on your own. But before that, you need to work 10, 20 questions, then solve this, right? So keep it as your last kind of thing to do. And tomorrow again, I think we can connect and move on from here. And tomorrow our major focus will be to use the difference quotient formula to find instantaneous rate of change. So gradient, slope, and instantaneous rate of change are kind of similar things, right? When we say that we are finding slope of a tangent line at a particular point, we could also say find instantaneous rate of change at that particular point. Now, as soon as we use the term instantaneous rate of change, we're actually moving on to practical examples. For example, I could be talking about displacement, velocity, and acceleration, correct? Now, acceleration is instantaneous rate of change of velocity, and velocity is instantaneous rate of change of displacement, correct? So we just jump into rate of change type of questions, which is extremely important application of this particular derivatives, correct? So that is another part which we are going to do, right? So now, I think I can stop sharing this screen and we'll get back to our discussion, right? So now, Amy, can you summarize what did we learn today?
So, where do I start? From the beginning?
Anywhere you feel like, yeah.
All right, so we learned about like the general formula. So m equals the limit when h approaches 0. So you got f a plus h minus f of a over h. And then we learned, so we can use the table to get to values. So let's say you start with by that x squared example, and as you go really close to let's say 1, so you keep going 1.001, you'll get to the value which would be the slope of the secant. And yeah, I think that's it.
So the correct word will be the slope of the secant approaches the slope of the tangent
The
at this
tangent.
point.
Oh.
And so finally you get the slope of the tangent. Right? So move on now. Next one.
What's next? So you said with the slope of the normal, it would be the negative reciprocal.
Perfect.
So yeah, it has to get equal minus 1.
Perfect. So we could solve many questions based on tangents and normals, right? How about rate of change?
Rate of change?
Yeah.
Well, that's a bit new to me. That's the different quotient thing.
So
Yeah.
I will touch upon rate of change tomorrow, take up many application questions on rate of change. Now,
Okay.
for you, the type of questions which I have created are actually very much similar to what is expected for GCSE level A. So these 4 questions are actually very relevant for you. Apart from that, the video which I'm going to share with you will have similar kind of questions, so you will have a good base to begin with. And once we have this kind of base for calculus, it is very easy to move forward, right? So you spend more time today. I mean, today you will have to work very hard so that tomorrow we could take a new topic, correct? And immediately after this, I'll actually share with both of you, Najib and Amy, the quiz on this particular topic. These 4 are your test question types and some more videos so that you're prepared for tomorrow. Now with Najib, we have a timeline. Within these 15 days, we have to complete derivatives. And in the next 15 days, we have to complete integration part, correct? So derivatives, we are going to go fast. It is definitely takes a semester to complete it, but here we are going to do it in 15 days, right? So we may have to work slightly harder as we move along. Now,
Yes,
Najib, could you summarize, and if you have any doubts, please speak up.
yeah, I have my own. I make my own questions, and because our questions are not very difficult at the in Germany, but I see that in England also they at the 11th they have.
Yes.
It's not. I mean it's a little bit difficult.
Yes.
Not difficult to understand, but it's a little complicated. They are making. You understand what I mean? But here in Germany, I think I find this the studies is easier than.
Okay, Najib, one, share with me the questions which you have created or which you need to be answered. I will answer all your questions. That is first.
Okay.
Okay, so just share with me the questions, or you can highlight if you are asked so many questions, you have to highlight the ones which is priority, right? Because I may be able to solve just few of them. Second, I really appreciate you, Najib, that you come from Afghanistan and where you've learned so much. And when you join the university in Germany, their standard actually is very high, but they are looking into the average group of students, and accordingly, they are bringing them up to the level of understanding. So initially, these things seem to be very easy, but don't get like confused or, that is not the level. Okay, so they're just bringing you up to this level. I've already seen what you are going to study soon, right? So soon it is going to be extremely difficult. It will be extremely difficult. Okay, so take care of that. And now I think we'll have to end the meeting as already 30 minutes have passed. Okay, so see you. I'll send you the recording of this posting also. Try to do the quiz questions and whatever I'm posting. Get ready for rate of change for tomorrow. Okay, so that will be great. Thanks a lot. So let's end the meeting now. Perfect.
Thank you so much, sir.
Thank you very much. Thank you.
All the best.
Bye.
I'm Anil Kumar. Welcome to my series on calculus. To begin with calculus, we actually need excellent foundation of algebra and many concepts about functions. In my series of calculus, I'll be taking even grade 11 students who know about lines and parabolas and who can jump on early and understand the concepts of calculus. So I'm going to keep it very simple and straightforward. We'll begin with extremely simple examples and then get into the intricacies of what is expected from a high school student doing calculus. So the very first question, of course, is what is calculus? We're going to answer that and then take a few basic concepts, which is slope or gradient of a line, secant and tangent on the curve, difference quotient equation, explore tangents as limit of secant, and take up examples with tangents and normals. That will bring us to the introduction of calculus, and we'll begin with finding limits of functions. So the very first question is, what is calculus after all? Well, in calculus, we will be focusing on two things. One thing will be to find slope on a curve. You can say slope at any point. On a curve. Now this part of calculus will be treated as differentiation. The second part of the calculus will be to find area under the curve. And that will be treated under integration. So as shown in the two diagrams here, we're trying to show you the extent to which we are going to go. We'll begin with understanding how do we find slope of a tangent line on any curve at any point. And the other thing will be to find area under the curve, and it could be under different curves, right? Combination of curves. So this is the part of differentiation, that is slope of tangent. We'll also refer this to rate of change. And area under the curve, as you can see here, will be part of integration. Perfect. Now from the slope of this line, we'll look into a few concepts. Let me make this point very clear here itself. We've been looking at circle most of the time, right? And as you can see, in a circle, a tangent only passes through one point. But here, you can see that the tangent to the curve actually crosses the curve also, right? So the basic definition which we had been following so far doesn't really work out. So we'll see what actually the definition of slope could be. So that brings us to the topic on slope and gradient of lines. So let's explore first slope and gradients, and then we'll get into the derivative part of the calculus. Slope or gradient of a line. As you know, equation of line is y equals to mx plus b. This is slope and intercept form where m is called the gradient or slope. For a line, as you know, for any line, the slope m, let me write a slope m, is basically equal to y2 minus y1 over x2 minus x1. If the points are, let's say point P is x1, y1, and point Q is x2, y2. So if you have 2 points given to you, then you can easily find the slope by using this particular formula, which is y2 minus y1 over x2 minus x1. Now, if you know the slope, then you can use the slope-intercept form of the line formula and find equation of the tangent line or equation of that particular line. So as a practice question to begin with, we have a diagram here. You need to find the slope of the segments in this particular diagram. So we are given the points which are A is 0, 0. Point B is given to us as 2, 4. Point C is given to us as 6, 2. Point D is given to us as 8, 2. And point E is given to us as 8, 0. You can pause the video, find slope of all these segments, which are AB, BC, CD, and DE. So that is an exercise. After that, you have to identify parallel and perpendicular segments and then write equation of the line B to C, which is this particular line. So that is the exercise. Well, some slopes are straightforward. So let's take up things like vertical and horizontal lines. So we know that, let me write down here, vertical line, slope is undefined, correct? Now in this case, the vertical line is DE. And then we know that horizontal line slope is 0, correct? So, and in this case, the horizontal line is CD. Even AE can be treated as a horizontal line. And when we are talking about identify parallel lines, then these two form parallel lines. Is that clear to you? Right? So we've got all the lines covered except for AB and CD. So let's find slope of AD. So let me write down MAB as slope of AB. Coordinates for A and B are given to us. Let me highlight these coordinates 0, 0, 2, 2, 4. And now we'll use the formula, which is y2 minus y1 divided by x2 minus x1. So y2 is 4. So we get 4 minus 0 over 2 minus 0, which is 4 over 2 or 2. So slope of line AB is positive 2. You can see when you move from left to right, it is increasing, right? So it is increasing. Positive slope. Now let's find the slope of the line BC. Slope of the line BC will be what? Now B to C, the points are, these are the points, correct? You can read also from the graph. And now y2 minus y1, so 2 minus 4 divided by x2 minus x1, which is 6 minus 2, gives us minus 2 over 4 or minus half. So minus means it is decreasing, right? As you can also see, the line is falling, correct? So it is decreasing line. Now these are the slopes of the lines, and you can notice that if you multiply these two slopes, which is to say that if you do slope of line AB times slope of line BC, what do you get? You get 2 times minus half, which is equal to minus 1. So these are perpendicular lines, right? So these are perpendicular lines. So negative reciprocal is the slope of perpendicular line, right? So sometimes we write negative reciprocal. So as you know, For perpendicular lines, the slope is negative reciprocal. So in this case, 2, negative reciprocal is minus half. So that makes a set of lines with negative reciprocal slope, so they are perpendicular. But if the slope is same, in that case, they are parallel, right? So we say same slope results into parallel lines. Correct? Now, many times we use the word slope and gradient. They mean same thing, right? So gradient of a line and slope of a line is one and the same thing. Now let's talk about tangent. Now when we say tangent, tangent could be to any curve, a line which touches at a particular point. Now that's the definition which we learn about tangents to a circle. So we'll begin with an example which is very familiar to us, right? So the question for you now is slope or gradient on a curve. The curve which I have selected is a circle. Find gradient of the tangent line at P 4, 3 on the circle x square plus y square equals to 25. Hence find the equation of tangent line at point P. So we are given this point P right there, and we need to find the equation of this tangent line. So coordinates of point P are given to us as 4, 3. How can we find this? Okay, let's join point O with P. So as soon as we join this point, we realize that it has to be perpendicular, correct? The radius of this circle is perpendicular to the tangent by definition. So we know that the radius is perpendicular to tangent. Perfect. Now, OP is the radius, right? So OP is the radius. We can find slope of OP, correct? Yes. So OP is radius. So what is the slope of OP? Well, we use the same formula, y2 minus y1 over x2 minus x1. So we know that the slope of OP is going to be y2 is 3, so 3 minus 0 over 4 minus 0. So it is 3 over 4. So that clearly indicates that slope of tangent will be, it is perpendicular, negative reciprocal. So we know that slope of line, let's say line is L. So slope of line L, or you can say tangent, is equal to negative 4 over 3. Is that clear to you? So we did the first part of finding the slope of the tangent line. Did you see? We used the concepts learned about the equation of line, and that was so simple. So that was the first part, and we did find the gradient of the tangent on this particular curve. Okay, we assume that point 43 is on the curve, but at times you may be required to check this, right? So you can check this also. So if you do 4 square plus 3 square, what do you get? You get 16 plus 9, which is 25, and so this point lies on the curve, correct? Now let's do part 2, which is find the equation of tangent line at point P. To find the equation of tangent line, we know y equals to mx plus b, and we know m is minus 4 over 3, and we have a point P which is 4, 3. So that should help us. We know we can substitute these points. So we get y equals to m is minus 4 over 3 x plus b. To find the value of b, we'll substitute the point 4 and 3. So let me write down 4 and 3 here. So we get 4 is the x value, right? So that we will just write it here first. So y value is 3. So we get 3 equals to minus 4 over 3. And x value is 4 plus b, correct? So from here, we can find the value of b. So we get b as equal to 3 plus 16 over 3, correct? Which is 9 plus 16 over 3, or you can say 25 over 3. So now we get our equation. So we can now write down the equation of tangent is what? Equation of tangent is y equals to minus 4 over 3x plus b, and b value is 25 by 3. So that is the slope and intercept form of the line, correct? Now you can always convert it to standard form. That may be a requirement also at times. So this could be written in standard form. Multiplying everything by 3 will help us provide the answer in standard form. And we can bring x to the left side. So we get 4x plus 3y minus 25 equals to 0. So I'd like you to verify this particular equation as the equation of tangent line on this particular circle. Correct? Let's take up the next question where we'll now look into the concepts of secants and tangents. Well, till now what we did was kind of a prerequisite for the calculus. So we're just getting started with rather brushing our concepts about the gradients, and we worked with a circle and a line. Now, here we have taken up an example with parabola, and the question here is related to secant and tangent. Let's try to understand what is a secant and what is a tangent. So we'll consider 2 points on this particular parabola, which is y equals to x squared. So let us say one of the point is at 1, 1, the other point is at 2, 4. Now, if I join these 2 points, right? So if I join these 2 points, then let me call this point as P and the other point as Q. So we have 2 points P and Q. So, and when we join them, what we get is called a secant. So secant is a line joining 2 points on a curve. That is what a secant is. Now, what is a tangent? As far as tangent is concerned, tangent will be a line which will be tangential at a point itself. So a tangent at P will be something like this. You get an idea. So that will be tangent. But how do we define this particular line? That is a big thing. Now, to get this concept, what we really do is we try to bring the point Q closer to point P. So when we have 2 distinct points, let me use the word distinct here. As shown here, very much far away, right? So when we have these 2 points, a line joining them is called a secant. Now consider that we bring Q closer, right? So let's consider of bringing the point Q closer to P. That is to say, if I take another point, let us say Q dash, or let's say R, which is closer, in that case, what we see that the secant becomes closer to the slope of the tangent. You get the idea. So to get the tangent, we actually consider a point closer to P, right? So we want tangent at P. So what we do is we move the point Q closer and closer. So as you move the point Q closer and closer to P, there will be a stage when slope of this secant becomes almost the slope of the tangent. So as you bring Q closer to P, the slope of secant becomes almost same as the slope of the tangent. Correct? So if I bring it much closer to P, if they're very close, in that case you will notice that the slope of secant and tangent becomes almost same, right? We say this condition technically as that the limit of secant approaches tangent. We're talking about slope, right? So that is what we actually notice here. So the idea is to, let's say if we have 0.11 for P and 24 for Q, then instead of x equals to 2, we can bring the point Q much closer. That is like 1.1, 1.01, 1.001. So based on this, we'll take a concrete example and then the concept will be absolutely clear. So in this particular diagram, it's the same diagram which we were considering earlier. We'll further explore, rather explain the situation. So here what we have is the 0.11 and the point, this is point P for us, and that is the point Q. So now we are considering another point which is almost halfway between P and Q. So you will notice that if I draw a secant which is going through the new point Q dash, which is almost halfway between P and Q, then the slope of the secant approaches the slope of the tangent. So this line is the secant for us. And the line in red is the tangent. So if I bring Q to Q dash, which is closer to P, then the secant slope is closer to the slope of tangent. Clear? So that is the concept. Now, based on this concept, we can do some calculations and truly find the slope, right? So in this particular table, what we have done here is that we have again considered the same points, P and Q. The graph is y equals to x squared. We have taken P as 1, 1, Q as 2, and square of 2 will be 4, right? So those are the points. So that's the point P at which we want to find the slope of the tangent line, and that's the point Q for us. Correct? So here is P and here is Q. So to begin with, we know that at 2, the value of x squared is 4. So that these two columns give you the values of x and x squared. Now, at this time, what we have is that much of difference between P and Q. Now, if we reduce this, bring it closer in this particular direction, the x value becomes lesser, right? So what we have done here is instead of 2, we have taken x values at 1.5, 1.2, 1.1, 1.01, 1.001, and 1.0001. You can clearly see that this is extremely close to 1, right? 1.001. So means we have approached P. We are not there exactly to find the slope. We need y2 minus y1 divided by x2 minus x1. So we need two distinct points. But the other point is not far away, very, very close. And we are saying the other point is 1.0001. So just 0.001 away from point P. You get an idea. So in a way, moving this direction, we are bringing the point Q closer to P, right? So that is Q closer to P, right? Now what is happening? We have just calculated the value for x squared, and in the third column, we have found the slope m. Slope from P to Q or Q dash, right? The new points which we are considering. Using this particular formula, which is y2 minus y1 over x2 minus x1, where the point P is 1, 1, right? That is our x1, y1. Is that clear to you? Since the coordinates of point P is 1, 1. So using the value x as 1 for P and P square, 1 square will be 1, we get these two values, x1, y1 as 1 and 1. And those other values of x and x square are picked from the table. So these two values, x and x square, are picked from the table. Okay? So we have x squared is the y2 value, which is 4. 4 minus 1, that is this value, 4 minus 1, divided by 2 minus 1, will give us slope of 3. And that is how the calculation is done. Correct? So using this way, we calculated the slope as the point Q approaches P. Now you can see from these calculations that the slope starts with 3 and ends up with 2.0001. So that means the slope of the tangent line, you can write that slope of secant approaches 2.0001 as Q is taken closer and closer to P, right? So you can clearly see that the slope is 2.2, 2.1, 2.01, 2.001, and 2.0001. So it approaches 2. And therefore, we can conclude that slope of tangent line is 2, since we are approaching 2. So from here, we learn that slope of tangent line is actually limit of slope of secant when the points are very, very close. You get an idea, right? So that becomes the definition for the tangent. Now, based on this definition, we'll actually develop another formula. That formula is going to help us further in calculus to find slope of a tangent line. Now let's again take the same question, which is slope of tangent on the curve y equals to x squared at P, which is 1, 1. So this time what we are going to do is we are going to take, that's the point P for us, and the coordinates are 1, 1. Right? So let me write down the coordinates on the left side. So we have a point P with coordinates 1, 1. So let's take another point Q. Now, this point Q is very close. We are saying it is only h away, right? So sometimes we use the term delta x, right? A small change, right? Or sometimes we use the letter h. So let's say this is at 1 and this distance is h away. So that means we are considering the point Q whose x coordinate is 1 plus h. Correct? So the x value has moved from 1 to 1 plus h. Now what is the y value for this? Since the function is y equals to x squared, the y value will be 1 plus h whole square. Correct? So that is going to be the y value. We already know that the coordinate point P is 1, 1. Now, what is the slope m equals to? Slope m is y2 minus y1 over x2 minus x1. So y2 here is 1 plus h whole square, that is y2, minus y1 is 1 divided by x2, which is 1 plus h minus 1. Now we can actually expand this using a plus b whole square formula, right? So let me write down the formula for convenience. So the formula which we are using here is a plus b whole square is equal to a square plus 2ab plus b square. Okay? So we are using this particular formula to expand 1 plus h whole square. So we get 1 plus 2h plus h squared, right? That is the expansion minus 1 divided by 1 plus h minus 1 is h. Now in this particular case, minus 1 plus 1 cancels, so we are left with 2h plus h squared over h. So we can write slope as equal to, taking h common, we get 2 plus h over h. Now you can cancel these h, right? What are you left with? You get 2 plus h. So we find that slope m is equal to 2 plus h. Perfect. Where h could be very, very small, right? Where h is very, very small as compared to 1. So that is a way to write very, very small. Normally, we may take a value of h as, let's say, 0.0001, right? So in that case, we get slope of m equals to 2 plus h means 0.0001. So that will be our answer using this particular method. Do you understand? Perfect. So let's go through it once again. We consider a point P and another point Q, which is only h away, right? So many books and many times we can say h is equals to like kind of delta x, small value. So sometimes we use delta x. Well, both could be used, right? Now, the y value, because the function is y equals to x squared, will be 1 plus h whole square. Finding slope using your standard formula, y2 minus y1 over x2 minus x1, which simplifies to 2 plus h. And we get our answer, which is 2 plus h. Depending on the value of h, how close it is to the given point, we can easily find the slope, and we calculate this to 2.001. Let's check what we did earlier. We did the calculations right from all these calculations, and we got the same result, 2.0001, when the point was 0.0001 away. So that is the h value which we are talking about, delta x, the change in x. You understand? So that is the delta x. Delta x is this value, 1.0001 minus 1, which is 0.0001, which I am using as h, correct? So in calculus, most of the time, h will be used, and therefore we are using this letter h instead of delta x, but to begin with, we could use either one of them. Perfect. So that is kind of connection between what you have learned so far and now what we are going to learn. Perfect. So that makes sense. I think it bridges the gap between the two. Now we have here a formula which is not so clear to see, but we'll actually work more on it so that we can explicitly understand this particular formula. Now we took a very simple example of a circle. Now it could be any function, any curve. So I've just drawn a function here, any curve, and shown a tangent line. And now the question here for us is slope of the tangent on the curve f of x at x equals to a, any point. So a is a general point and f of x is any function in general. Now let's see what we did. We are trying to find slope, right? So once again, we are only trying to find slope of tangent on this particular function at a given point a, right? So when I say x equals to a, let me write down. When I say x equals to a, in that case, what is the y value? Y value is f of a, correct? And therefore, the coordinate point is a and f of a. Is that clear to you? So we want to find the slope of tangent line at this point, which basically is at A. Is that clear to you? And the y value for this point will be f of A. Is that clear? Perfect. Hmm? So consider this. And we call this point in general as P. Now, let us consider another point very, very close to P. Okay, so very close to P, it could be a point which is, let us say right there. We are calling this point as Q. Now, as far as point Q is concerned, it is very close, and so the coordinate value is A plus H. Correct? So the y value will be f of A plus H. Is that clear to you? So that becomes the coordinate point Q value. Now, what is the slope? Slope m is y2 minus y1 over x2 minus x1. So y2 for us is this value, f of a plus h, minus y1 is f of a, and x2 is a plus h, minus x1 is a. Correct? So we get slope m as equal to f of a plus h minus f of a, means value function at a, divided by h. Is that clear to you? So that becomes slope. And this slope, because this is between 2 points, we call this as slope of secant. Is that clear to you? Now, as soon as I say that h approaches 0, right? So that is very, very small. Then it becomes slope of a tangent, right? Then it becomes m equals to f of a plus h minus f of a over h. And we say where h is very, very small as compared to 1. So that means it is very, very small. Now this is so commonly used that we use a word here which is called limit. So we say this word is called limit, that h approaches 0. That means very, very small. And now we'll write our final equation of slope of tangent as m equals to f of a plus h minus f of a over h, where h approaches 0. Is that clear? Correct? And now we could also use the word limit here, which I'm not really using it at present, but I'm introducing you to this. So when we say h approaches 0, we say in general in calculus where the limit of the value of h approaches 0. It is not 0, but it is very, very close to 0, and we normally take this as 0.001. Correct? So I hope you have understood the concept and also this particular formula, which we'll call as difference quotient formula, right? So, and based on this, let's take an example. So what we have learned here is, let me just summarize this, and that will help us to answer the question also. You can actually go through the question at present. So we are now saying that slope of tangent is m, which is equal to limit of h approaches 0 for f of a plus h minus f of a over h. Correct? Slope of tangent at x equals to a on f of x. So that is any general function, correct? Any general function is m limit h approaches 0 for the value of the function at a plus h, very close by. So graphically, I could say that on, let's say, let's sketch a graph here. Let's say we have a graph, something like this, correct? So in that case, if we are interested in finding slope of a tangent at a point which is kind of here, right? In that case, what are we considering? We are considering 2 points. This point is what we are calling as A. The other point is very close, which is A plus H. You get the idea. So the value here is f of A, and the value at that place on the curve is f of A plus H. And slope of the tangent is this particular triangle. Do you understand that slope? And that is what is being written here as f of A plus H becomes the height, and this h is the run. So that is the rise over run in the given situation, right? So that is the basis on which we are going to find slope of a tangent line. Absolutely clear, right? Now the question. The question says, consider the function f of x equals to x cubed plus 1. Find slope of tangent on the curve of f of x equals to a. Question 2. At point Q on f of x, slope of the tangent is 12. Find the coordinates of Q. And question 3 is, find equation of normal at Q. So you can now pause the video, answer this question, and then look into my suggestions. Okay, so let's begin with the very first question, which is, consider the function f of x equals to x cubed plus 1. Question 1 is, find slope of tangent on the curve f of x equals to f of x at x equals to a, right? Now, we know that the slope of tangent m is equal to the value of the function at a plus h minus f of a divided by h, where the limit h approaches 0. So we'll write like this, where h approaches 0. I don't want to use the limit term now, but we can always use it. Okay. So we are given the function f of x as equal to x cubed plus 1. Now, that really means, what is f of a equals to? A means substitute a there, so get a cubed plus 1. And what is f of a plus h equals to? F of a plus h will be, replace x with a plus h. So we get a plus h whole cube plus 1. Correct? Now, you need to expand this to get the value. So it is, you know, the Q formula. You can apply the Q formula. So let's write down here, f of a plus h is, when you expand this, a cube plus 3a square h plus 3ah square plus h cube, right? So you get these four terms plus 1. So that is what is fa plus h. Now, we'll substitute these values and find the slope m. So m will be a cube plus 3a square h plus 3ah square plus h cube plus 1 minus f of a. And f of a is a cube plus 1, correct? And all this divided by h. Clear? So in these terms, when you work, a cube will cancel with a cube and 1 will cancel with 1. What you are left with are terms which have h in it. So that could be written as 3a square h plus 3ah square plus h cube, right, divided by h, which is equal to, you can take h common, and you get 3a square plus 3a h plus h square over h. Now you can cancel the terms h and h. So what do you get? You get m as equal to 3a square plus 3ah plus h square. Correct? Now, when we say that h is very, very small, right? So we are saying h is very small. In this case, h is very, very small as compared to 1. In that case, these terms become negligible. And approximately, we get this as 3a square. Is that clear to you? Because h is very small. So if you put h as 0.001, the square will be extremely small. And the term 3 times 0.001 will be very small as compared to 3 times a square, right? So those terms are small, and therefore we get slope of tangent in general is equal to 3a square for the given function. Is that clear to you, right? So in this particular case, we have used the formula, which is a plus b whole cube, which could be a cube plus 3a square b plus 3ab square plus b cube, correct? So we have used this particular formula to expand at this stage, right, getting that particular answer. And then we have used our difference quotient formula to find the slope. So we did part 1, finding the slope of a tangent line on this particular graph in general. So that is our general solution, right? So it's kind of important to understand. This is also referred to as general solution. And the equation is called difference quotient equation. Since it is quotient, right, division of differences, fa plus h minus fa over h. Perfect. Now let's take up question number 2, which is find q on f of x equals to x cubed plus 1, where the slope of the tangent is 12. Now, we have understood one thing, that for the function f of x equals to x cubed plus 1, slope is at any point f of a is 3 times a square, correct? So that is what we just found, right? 3 times a square. So we are using this value. Now we are given that the slope is 12. So we can say 3 times a square is equal to 12. So a square is equal to 12 over 3, which is 4. And that means a will be plus minus square root of 4, which is plus minus 2. So on this particular function, we'll have 2 points where the slope of the tangent is going to be 12. And those are at a equals to plus minus 2. So what is f of a going to be? So f of 2 will be equal to 2 cube plus 1, which is 8 plus 1, 9. And f of minus 2 is going to be minus 2 cube plus 1, which is minus 8 plus 1 or minus 7. So these are the 2 points. So we get 2 values of q, right? So in this particular case, we get q as a point which is plus 2, 9, and we also get q dash, which is minus 2, minus 7. Perfect. So these are the 2 values where the slope of the tangent is 12, right? So if you actually graph this particular function, which is x cubed plus 1, so it's the cubic equation which is kind of moved 1 unit above, and the 2 points where we are getting the same slope of 12 could be, since it is quite symmetric, right? So it could be kind of like this. Does it make sense to you, right? So that is how we are going to get these 2 points, right? Something like this. So that will be a rough sketch. Now let's do the next example, which is, now we found one thing, that is we have now 2 points. So we have 2 points with slope uh, of 12. Okay. Now the next question here is the last question of our video, which is find the equation of normal at q on this curve. So we have 2 values of q. So there will be 2 different equations, right? So we have the function f of x equals to x cubed plus 1. We'll take the value of q as 2. So for 2 will be 8 plus 1, 9. And for the same function, we also have minus 2. So minus 8 plus 1 is minus 7. And for both, we know that the slope m is given to us as 12. Okay? So we can write the equation of normal. So to write equation of normal, we have to write first slope of normal. Correct? So let's begin with writing slope of normal. So normal slope, let me write as n1. So it'll be minus 1 over 12, correct? So normal slope, let me write here, n will be minus 1 over 12, correct? That is the slope. So the equation will be what? Y equals to mx plus b. So you could write this as y equals to slope of the normal we're talking about, minus 1 over 12x plus b. We can use the point q, which is 2 and 9. So 9 equals to minus 1 over 12 times 2 plus b. Taking this, that is 1 over 6. 9 plus 1 over 6 equals to b. And that is 6 times 9 is 54. So it is 54 plus 1 over 6 equals to b, which is 55 over 6, right? So we get the equation of the line as y equals to, slope is minus 1 over 12x, and the b value is 55 over 6. Clear? So that is one of the equations of the normal. The second one, which has a point q as minus 2 and minus 7, right? So we'll again use the same equation of y equals to mx plus b. So we have y equals to slope of minus 1 over 12x plus b. However, the points are minus 7, the y value, and minus 2 is my x value. So it becomes minus 7. That slope, minus and minus is plus. So when it comes on this side, will be negative. Negative 1 over 6, right? So 6 times 7 is 42, negative, minus 1 over 6. So we get the value of b as negative 43 over 6. And so the equation of line will be y equals to minus 1 over 12x minus 43 over 6. Perfect. So in this particular case, we'll have 2 normals as expected actually. Since here you could see that the normals will be at both the points, right? Kind of like this, correct? So those are the two normals. We say normal 1 and normal 2. Is that clear to you? So that is how we could actually solve some related questions on tangents and normals. So with that, here we have a brief discussion, rather introduction on calculus. Now we will use our equations, especially the difference quotient equation which we talked about. And let me once again write down this difference quotient equation in a formal way. So we will normally write this as m equals to limit h approaches 0 for f of x plus h minus f of x over h, right? So that is how normally we are going to write this. Limit means that the value of h is approaching 0. It is not 0, but it is very, very close to 0. So you could treat this as 0. That is what it means, okay? So I hope you have understood this particular equation. This equation is also called difference quotient equation. From here, we'll understand more concepts about limits. We'll use this particular formula, which is called difference quotient equation, to find the derivatives, which will give us slope of a tangent line on any point of a curve. And that's the beginning of calculus. So I hope you understand and appreciate it. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.